Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video we'll start with a new chapter, Light, Class 7, Chapter 11. So, to begin with, you might have seen a beam of sunlight when it enters a room through a narrow opening or a hole. You may have also seen beams of light from the headlamps of scooters, cars and engines of trains. So now what they are saying is that say you have a dark room and say you have a house of roof tiles. So in that case what happens, there is always some or the other small opening that is present over there. So when there is sunlight or there is some kind of light that passes through that hole, it comes down into the room as a beam of light. Also, if you see the headlights of bikes and cars, you also see that beam of light. Similarly, a beam of light can be seen from the torch. Even when you turn on a torch, you can see that beam of light that is produced. You may have seen a beam of searchlight from a lighthouse or from an airport tower. Even lighthouses, see here, they also have that beam of light. See like this. This kind of beam of light is present. So what do these experiences suggest? So what do we see in these lights? First of all, we see it depends on how powerful the light is. If now see, if the hole in your roof tiles is very small, then the beam of light that will be passing through will also be small. But if you compare your headlights of your cars or your bikes, those are bigger beams. Depending on the size of the torch also, the size of the beam varies. But now there is one common thing in all of these examples. That is, we always see a straight beam of light. In none of the cases have we seen like a wave or the light going in curved direction. It always goes in a straight direction. It goes like this. It is always like this. This is the this is the path it follows. It always goes straight. Never ever have we seen light that goes in this direction or even in curved direction. No, light only travels in this straight line. Okay, so now light travels along a straight line. Bojo recalls an activity he performed in class 6. In that activity, he looked at a lighted candle first through a straight pipe and then through a bent pipe. Why was Bojo not able to see the candle flame through a bent pipe? So now what they are saying is here what Bojo did was he took a straight pipe and he looked at the candle. Here he took a crooked or a curved pipe. What was happening here was the flame or the light was visible to him. But here it was not visible to him. So now why was this happening? This is because light always travels in a straight line. So now see here what will happen. Light travels in a straight line. So this light will go actually like this, right? But now here you see there is a change. Light will travel like this and then maybe it might not go anymore curve. So that is the reason why Bojo was not able to see the light beam. This activity showed that light travels along straight lines. Now how can we change the path of light? Do you know what happens when a light falls on a polished or a shiny surface? Now we are saying that light travels in a straight line. Now say if uh, I want the beam of light in some other direction, then what do I do? How do I change the direction of that beam of light? Also, have we ever seen what happens if we take light and we reflect it on a very polished or a very shiny surface? We'll see that ahead. Reflection of light. One way to change the direction of light is to let it fall on a shiny surface. So now one way they are saying is that we can reflect or we can let the light fall on a very shiny surface. Now for example, a shiny stainless steel plate or a shiny steel spoon can change the direction of light. Now steel is what? It is shiny, right? It has that shiny, bright texture. So then if you hit light on it, or if you let light fall on it, that will change the direction of light. The surface of water can also act like a mirror and change the path of light. So even water can act as a mirror, and therefore it can change the path of light. Now, have you ever seen the reflection of trees or buildings in water? Now often we see this. We can see no reflection of different trees. Say there is some clear water besides a roadside, so you can see clear image of that trees which are there in that water. So why is this happening? That is because of the reflection of light. Any polished or shiny surface can act as a mirror. So what they are saying is that any polished or any shiny surface, say water, say stainless steel, all these things can act as a mirror for the light. What happens when light falls on a mirror? Now you have learned in class 6 that a mirror changes the direction of light that falls on it. So what a mirror can do is, mirror can change the direction of light. Now, and this change of direction of light is called as reflection of light, because see, now there is a mirror and I'm hitting some light. It is changing the direction, means the direction of light is basically in this direction first. Okay, so say this is my mirror and I'm hitting the light in this direction. So this is in a straight line. Now the minute it will hit the mirror, what will happen? It will get back. It will change its direction. It can go in any direction. So this is known as reflection of light. Activity. Take a torch, cover its glass with a chart paper which has 3 narrow slits as shown in figure. So you have to take a chart and you have to cover the torch with this such kind of 3 narrow slits. Then spread a sheet of chart paper on a smooth wooden board. So this is the wooden board. You put a nice sheet of chart paper over it. Then you fix a plain mirror strip vertical on the chart paper. Then you place this mirror on the chart paper. Now direct the beam of light on the mirror from the torch with slits. Place the torch in such a way that its light is seen along the chart paper on the board. Now adjust its position so that the light from the torch strikes the mirror plane at an angle. So now what they have told is you have to adjust this mirror in such a way that this is hitting this wall over here, this mirror over here, and you can see exactly the lights over there. Does the mirror change the direction of light that falls on it? Now move the torch slightly to either sides. Do you find any change in the direction of reflected light? So now what we'll see is, see, here we can see the light that is being hit. See, this is the light that we have reflected. Okay, we have shined onto the mirror surface. Now see, this part which you can see, which is basically coming out, is the reflected light. So there is some light that is getting reflected. Initially the direction was this. Now the direction has changed to this. So there is a change in direction. Look at the mirror along the direction of the reflected light. Do you see the slits in the mirror? Yes. See, you can see those gaps also. We have cut slits over here. So that gap wherein that light is not passing is also visible here. This is the image of the slits. This activity shows how light gets reflected from a plane mirror. Now, another activity. Place a lighted candle in front of a mirror. Try to see the flame of the candle on the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror. The candle itself is the object. So now when you take a mirror and you place a candle over here, you can see exactly another candle at the other side. It appears as if there is another candle behind this mirror. But this image, this candle which appears behind the mirror, that is the image of the candle that is formed. And this candle over here itself is the object. Now move the candle to different positions in front of the mirror. Observe the image in each case. So what will happen, even if you move this candle from this direction to this, what will happen? You can still see the candle right over here. There will be no as such change in the candle that will be happening. Was the image upright in each case? Did the flame appear on top of the candle as in the object? Such an image is called as erect. An image formed by a plane mirror is erect and of the same size as the object. So now this mirror was plane. So no matter where you moved this candle, the image still remained the same. So therefore now what they are saying is that it was an erect image. Erect meaning the size of the object does not change in the image that is being formed. Now place a vertical screen behind the mirror. Try to obtain the image of the candle on this screen. Can you get the image on the screen? No. Now place the screen in front of the mirror. Can you get the image on the screen now? No. You will find that the image of the candle cannot be obtained on the screen in either cases. Now what they told? See, place an object over here, another object over here and one behind here, and try to get this image on that object. What we are trying to do is basically reflect this image onto another object. But that didn't happen even when we kept the object behind the mirror or in between this candle and the mirror. It didn't happen. What about the distance of image from the mirror? Let us perform another activity. Now say take a chessboard over here. So what they have told is take a chessboard here. Then you place this vertical mirror over here. So now then you count 3 and from the edge you keep it the sharpener in the third box. And you will in the mirror image also you will see it in the third box itself. Now you shift it to anywhere in the board. So that will give you the same image. So there is no change that is happening. Did you find any relation between the distance of the image from the mirror and that of the object in front of it? No. You will find that the image is at the same distance between the mirror as the object is in front of it. So here also see it is 3 boxes away. Here also it is in the third box. Now verify this by placing the object anywhere on the chart paper. It will still remain the same. Now, right or left? When you see your image in a plane mirror, is it exactly like you? Have you ever noticed there is one interesting difference between you and your image in the mirror? Let us find out. Now see, I am right in front of this camera. Now if I raise my this hand, you all will be able, I am currently raising my left hand. But what you all will be able to see is that I am raising my right hand because the mirror image is raising its right hand. So that is one thing we notice even in our mirrors. If you raise your left hand, the mirror image will raise its right hand. So why now is this happening? Stand in front of a plane mirror and look at your image. Raise your left hand. Which hand does your image raise now? Now touch your right ear. Which ear does your hand touch in your image? Observe carefully. You will find that in the mirror, the right appears to be left and the left appears to be right. So when I raise my left hand, you all will be able to see that I am raising my right hand. But if I raise my right hand, you all will be able to see that I am raising my left hand. Note that only sides are interchanged. So what we are saying is that only the sides are interchanged. Not the whole image is not changed. As in now I am sitting up straight. Does that mean my image will become upside down? No, it will still appear up straight. Now write down your name on a piece of paper and hold it in front of a plane mirror. How does it appear in the mirror? It will appear reverse. So now see here. We have seen many times on the ambulance, it is always written like this in the reverse form, right? Why is it so? Now can you understand why the word ambulance is written as it is in figure 11.9? Why? Because when the person, say I am driving or I'm riding, so when I see the ambulance behind, in the mirror what I will see is the mirror image of that ambulance name that is written. So I will be able to read it correctly. Okay, so I will read it as in this form and not the reverse form. That is why what they do is they write it in the reverse form on the ambulance. So it is also a duty of everyone of us to allow an ambulance to pass without blocking its way. So we should never block a ambulance. We should always try and make space for it to pass. You might have observed that inside mirrors of a scooter or car, the images of all objects appear smaller than the object themselves. Have you ever wondered why is it so? Now this scenario we used to see in older bikes, as in like few years back this thing was there. Even on the mirror it used to be written, let objects in the mirror appear closer than they actually are. So that was because by that time the mirrors were not so advanced. Now you don't see that written because now those mirrors can accurately tell how far or close the object is. So that was it for today's video. Please don't forget to like, share and subscribe to the Bodhi Academy. Thank you.